Hello, and welcome to the second video lecture on system security. This time we're going to have fun with hacking. Well, I'm not going to teach you how to hack, but I'm going to teach you what hacking is, and we're going to look at some different related issues connected to this that would be useful for you to know for a GCSE exam. So what is the definition of hacking? It is to gain unauthorized access to data in a system or a computer. The reasons as to why people attempt hacking are various. There are a lot of different motives. So for example, theft. Some cases of hacking are straightforward attempts to steal money or saleable information. So you might want to gain access to bank account information or credit card information. You might want to contravene copyright laws in the theft of intellectual property. Often you're trying to defraud individuals or organizations, so it's all about a straightforward crime to make a bit of money. Malice. In order to do damage to some person or organization with whom the hacker has an actual or imagined grievance. Sometimes this involves making a political point. So if you don't like a company or a business, maybe they fired you, or they mistreated a friend of yours, or you just have some kind of imaginary slight, you can hack them in order to cause damage. Fun. Some hackers break into computer systems just to prove that they can. Often these are teenagers or young people, and they just enjoy the problem-solving aspect of it and don't really consider the fact that they're actually breaking laws. Ethical reasons. Some hacking attempts are genuine attempts to expose system security so that they can be fixed. So you break the security and then you show them, that company, how it was broken in order for them to actually improve their security in the future. However, whatever the reason people do hacking, unauthorized access to computer systems are illegal in most countries. So certainly in the UK, if you're trying to gain unauthorized access to a computer system or network, you are breaking the law and you can be arrested and get into a lot of trouble for it. So let's have a look at some common hacking strategies so we can think about ways that we can avoid this happening to us or businesses we work with. So most hacking involves trying to get hold of passwords, because once you have passwords, preferably passwords with high levels of access, you can get a lot of access to computer systems and gain access to the information that hackers need. Hackers can try common passwords that lots of people use. So even nowadays, and this is recorded in 2018, lots of people will use password as their password, or 12345. Even altered attempts like this are really easy to guess. Users' personal details can lead to their passwords if they are known. So for example, a lot of people use their children's names or their pets' names or birthdays or things like that. It's very easy for hackers to use social media, things like Facebook, company websites, other things like that, to find out all about a target. And if you're using anything like this for a password, it'll be very easy for them to try and work out what it is. So you shouldn't be using anything like this for your password. So often the easiest way to gain hold of somebody's password is simply to ask. People are very trusting and will often give up a password to anyone who asks for it, especially if that person seems to have a plausible reason to request it, such as claiming to be a repair technician. This is sometimes called social engineering, using people skills to get information. The term social engineering was coined by a very famous hacker in the 1990s called Kevin Mitnick. If you know anything about hacking, he was #1 on the FBI's most wanted list for a number of years. So when people think about hacking, they think about Hollywood movies. You've got the nerd, the geek in the basement. He's got 10 computers, 20 computer monitors in front of him, and he's typing away furiously, trying to beat that countdown in order to get the security password. But that's not really how things work. If you want a password, it's easy to ask people, to trick people into giving you their login details. So this is a kind of common situation. Brenda works in accounting. She's in her office one day. The phone rings and it's somebody saying, "Hi, I'm Bob in accounting. There's a problem with your account. We need to reset it. Can I have your username and password? Thanks." And Brenda just gives out her username and password. No problem. Because she's working in the office, she trusts the person calling her must be who he says he is. But he could be a hacker, and now this person has Brenda's account details. He can log on as her. So again, this is a very simple example of social engineering. You just ask for it and people give it to you. A more advanced form of social engineering is something you may have heard of before called phishing. So, spelt with a PH to separate it from actual phishing, PHISHING. So again, this is often used to obtain sensitive information like people's credit card details, passwords, user IDs, and things like that. So what happens is that the hackers send out emails, and these are pretending to be from a bank or eBay or some other well-known website, pretending that they need your credentials to fix some invented problem. So it might say there's a problem with your bank account. Please click here to log in and fix the problem. People click on the link in the email. It takes them to what looks like their bank's homepage, but in fact it's a fake website. And when they enter the details, the hackers have it. They've phished that person, and now they can use their details to gain access to their accounts. When you see a phishing email, you may notice some strange language or spelling mistakes, and that's often because the people doing the phishing might be from other countries. However, as the years have gone on, phishing attempts are getting a lot more professional, and often they may fool many users. Okay, so that's me checking the auto spell and not checking it myself. So of course that should be fool many users. I'm a fool, ha ha ha. But seriously, it might sound a bit obvious that phishing would work, but again, even major corporations have been hacked by using phishing. People click on a link, they enter their details, and now the hackers have it. So if you take a look here, this is a phishing email that I myself received a few years ago, purporting to be from PayPal. So you can see at the top here, it says it's from service@paypal.co.uk. But this person is trying to spoof this email address. And my email software has actually picked up on that and has actually given me the real email. Of course, that might not happen, and you might just see the spoofed email account. And then we've got the standard, there's something wrong with your account and you need to log in. There's some kind of issue, and it uses a bit of security language and tries to alarm you to get you to click to get you to log in. But if you notice straight away, there are a couple of small issues here. We've got a little mistake here. We have some unusual activity in your account. Okay, going to be suspicious here. English seems to be a bit wrong here. And then the link at the bottom, well, let's take a look at that. Yeah, that doesn't look like the real PayPal address. Sometimes it might be more convincing than that. They might have a spoofed web address, or they might have a web address that looks very similar to the real PayPal address, but slightly misspelled, something that's easy for people to click on. So if you do get a message like this and you're worried and you think even it might be genuine, investigate it, but do not click on any links that they give you. This is very bad. What you should do is go to your real PayPal account, so enter it straight into the web browser yourself, enter your bank address or Amazon account, enter it directly in, or do a Google search even, and then access your account through that mechanism. Don't ever click on any link in your email because it could be a phishing email. You'll be taken to a fake website. It'll look realistic, but it's very easy to copy HTML. And then when you enter your details, you're phished. They have your access to all your account information. So let's look at some more common hacking strategies. If basic social engineering isn't going to give them access to your account, there are other tricks they can try. We have the dictionary attack. This uses a word list file or a series of word list files. This allows them to try thousands or millions of possible words from different sources such as dictionaries. So if your password is any password in the English language, that is going to be hacked really quickly. The hacker can download every word in the English language or every word in the French, German, Spanish, Chinese, Russian, whatever dictionary, and then try millions of possible words every second and try and break your password. They can also download password lists containing millions of known passwords that have been stolen and hacked by hackers previously. So again, there have been a lot of famous hacks over the last 5 or 10 years. Hackers have got access to real password lists from poorly secured websites, and now they have these real passwords. So they can download them in a list and just try every one of these passwords to see if they can get into your account. So if you're using any sort of common password, it's going to be hacked really quickly. You've also got what we call a hybrid attack. This builds on the dictionary method by adding things like numbers and symbols to the dictionary words. So for example, if your password is elephant12 and you think, oh well, nobody's going to guess that, you're mistaken. The dictionary will have elephant in it, and the hybrid attack will quite happily add numbers and common symbols to the beginning, the middle, and the end in order to try and guess your password. That's not going to take very long to crack at all. You've also just got the brute force method. This is when the hacker uses software to try every possible combination of letters, numbers, and characters until the correct combination is found. So they'll try A, and then they'll try AA, and then AAB, and then AAC, etc., until they've tried every single keyboard combination to try and crack a password. This way can crack short passwords really quickly, but as the length of the password increases, the time taken to discover it by this trial and error method increases exponentially. So if your password is 5 or 6 characters, it can be cracked very quickly using brute force. If it's 15 or 20 characters, it's very unlikely this will ever work because it would take thousands and thousands of years to run all the keyboard combinations till that point. So a nice diagram here just to kind of illustrate this point that for brute force hacking, password length is very important. We've got days to crack over here, and we've got the password length over here. And we've got various ways of generating this brute force attack. And you can see for very short passwords, they're going to be cracked very, very quickly, time 0. But as the password length gets greater and greater, it becomes exponentially more difficult to crack. So here we can see the different mechanisms. We've got using just a standard desktop PC. We've got using a graphics card because graphics cards are really good at running these tasks over and over again. And then we've got the idea that you can rent a lot of servers from somewhere like Amazon and then use that to run your software on a very powerful system. These systems are a little bit old. We've got the i7-980, we've got a Radeon 6970, but even using modern systems, it's going to be fairly comparable, but a bit faster. But again, the key thing to take away here is if you have a long password, it's going to be really difficult to crack. If you've got a short password, with brute force hacking, they're going to get that in seconds or minutes or hours, but it's not going to take them very long at all. So let's have a look at a bit more about that. So the easier a password is to remember, in many ways the easier it is to crack. This is why many password requiring installations insist on the passwords using upper and lowercase letters, numbers, and special characters. Because the greater the pool of characters you draw from, the more difficult it is to brute force hack. So you can see here we've got let me in, and that's not a very secure password. It's a common password, it's not very long, it's going to be hacked. Whereas something like this, wow, that's going to take thousands and thousands of years using current computer technology to crack. The problem, of course, is anybody going to remember this sort of password? you're probably going to have to write it down or something like that. That's going to be an issue, because once you write it down, it's easy for somebody to get access to it. So we can use things like these kind of password strength checkers to try and assess the password strength that we're using, that our customers are using on our websites. Again, you've got this problem that passwords that are difficult to hack are also difficult to remember. People are not very good at remembering random alphanumeric sequences. So this is when I like to bring up XKCD, which is a web comic series. They do lots of comics about IT and technical issues, and some of them are really perceptive. So the basic idea here is, if you want to create your password that is easy to remember but difficult to hack, you can just use a combination of 4 random words. So in this case, correct, horse, battery, staple. These are unconnected words, 4 of them chosen at random, and this is incredibly difficult for a computer to hack. Whether using brute force or dictionary attacks, because you have these unrelated words, it's going to take a very large amount of computational power and a lot of time to try and hack. This password using current technology is pretty much unhackable. However, it's really easy to remember. So this is a good way of balancing out getting a password that's easy to remember but is also really difficult to hack. Just choose 4 or 5 random words, and there you go, you've got a really strong password that you can remember but can't be hacked. With one proviso, and that is you don't reuse the same password. Because if you use the same password for different sites and different pieces of software, it's not going to be secure anymore, because if one of those sites has bad security and somebody gains access to your password, it'll end up in a dictionary list and it'll just be hacked really quickly in the future. So it works, but that's one password for one site. So let's look at some other forms of hacking. Let's look at denial of service attacks. This is an attack on a user's computer or network in an attempt to prevent anyone making use of the resources that are there. The purpose of a denial of service attack is not to penetrate the site's security or gain access to the information inside it. It's simply to shut it down and prevent other people from accessing that website and its resources. It is commonly done for the purposes of extortion. Either pay us money or we're going to do a denial of service attack and block your website for 2 days. Or to make a point. Sometimes it's political, sometimes it's linked to terrorism, sometimes it's all about hacktivism. We don't like your company, we don't like your government, so we're going to shut down your website. These often work by using up the bandwidth so the service becomes unobtainable. Sometimes a computationally intensive task, I'm getting a bit tongue twisted here. Sometimes a computationally intensive task is given to the target computer, thereby taking up a lot of processing power for a long time. And that means while it's working on the task, other users can't access it. Another approach is to infect many innocent computers with a piece of malware that turns them into zombie computers, what we call a botnet, that can simultaneously flood a website with too many requests for it to handle. So if you've got a website that can handle 1,000 people accessing it at once, and you can have a botnet of 1,000 zombie computers try and log in at the same time, that'll use up all the resources and the real users won't be able to access it. This can damage routers and break routing tables and disrupt web traffic around the internet. Denial of service attacks are often perpetrated by individual vandals, although they can also be used as a form of cyber warfare, of cyber crime. Again, sometimes governments might launch this type of denial of service attack against other governments. Again, groups of hackers might do this against businesses that they don't like. It is very difficult to counter denial of service attacks. Once somebody's started it, it's very hard to mitigate it. You just almost have to wait for it to stop. Although, of course, nowadays, with the increasing bandwidth on networks with better firewalls, these are less dangerous than they used to be, but still a really big denial of service attack can disrupt a major website, can disrupt entire sections of the internet, in fact, if it's very well done. So often when we hear something like hackers took Facebook offline or Amazon offline for 6 hours, it's not because they broke the security and gained access to it. They just did a denial of service attack that was big enough to block legitimate users from getting access for a certain amount of time. If we have a look at this diagram, this just helps illustrate one type of denial of service attack. We've got a hacker here. He's got access to hundreds or thousands or tens of thousands of zombie computers. These are all infected with a piece of malware. That means the hacker can have access to them, and he can then tell them all to try and log in to the same target server at the same time. It overloads the server, and a legitimate user can no longer gain access to this website. There are lots of different types of denial of service attacks. Often we refer to them as DOS, denial of service attacks. This particular diagram here is what we call a distributed denial of service attack, or DDoS. You've got a further type that's actually called an amplified distributed denial of service attack. And you can find more information about these if you look at other videos online. You don't really need to know the difference between all these different types of denial of service attack at GCSE level, as long as you can give a basic description of what it is and how it might disrupt the target server. Data interception. So this is sometimes called a man-in-the-middle, MITM attack, or a passive attack. So as we should know, networks send data in the form of data packets. These packets of data can be intercepted en route. So here we've got the user, and they're communicating with a web application, and they're hoping that their data is going backwards and forwards. But sometimes you get an attacker, and he's actually getting your data packets, and then he's intercepting them, and then he can gain access to the information before sending it on. The web application sends the data packets back again. He can intercept them and read them, and then send them back on to you. So you think you're connecting directly to the web application, but in fact it's all going through this man in the middle who has access to your packets of data. So again, instead of the data packets being sent from the client computer to the server and back again, an attacker inserts themselves in the middle, hence the term man-in-the-middle attack. Confidential data can be extracted from these intercepted data packets. So if your data is not secured, you can get access to passwords, credit card information, login details, sensitive emails, things like that. Wireless communications are particularly vulnerable to data being intercepted by this. They can sniff the packets of data quite easily with Wi-Fi because they're not constrained by needing access to physical cables. You can download what we call packet sniffing software online, and you can use this to monitor wireless traffic and then try and pick up on these data packets. If they're not secured, you can gain access to confidential information. Intruders can access Wi-Fi signals from over 300 meters away, so they can easily escape detection. What often happens is you get an attacker, they go to a cafe perhaps, and they set up a little Wi-Fi hotspot, and they give it a similar name to the cafe, and then people click on it by accident when they're sitting there having their coffee, surfing the internet. The hacker can then examine all the packets of data going backwards and forwards, and try and gain access to some confidential information that they can use. The best way to defeat this sort of data interception is to use some form of strong encryption. So hopefully your website's using HTTPS, because that means you have a nice secure encrypted connection between that and the web server. Hopefully if you're using Wi-Fi, the Wi-Fi that you're going to be using will be something like WPA2 or some other secure standard that means your data is encrypted, and all this will help mitigate the damage done by this sort of attack. Although, of course, things get more complicated, and the more you research this, the more that you can see that people can do quite lots of clever man-in-the-middle attacks to try and get around this sort of security. But basic idea is if you're using strong encryption from endpoint to endpoint, any intercepted data should be unintelligible and shouldn't be of any use to the attacker. So let's have a look at another form of hack. This is an SQL injection. And this is a little bit more complicated, so bear with me as we go through this. So many websites store their data on a database server. So for example, all your posts and pictures on Facebook, all the products and product information on Amazon, all the usernames and passwords and credit card numbers are all stored on databases. So if you have a look at the diagrams here, you can see the user is accessing the website server, but then the website server needs to access the database server. And again over here, you're accessing the web server and that's sending information back again. But for things like product information, photographs, images, passwords, the web server is accessing a database that has all this information on it. Now, as the client, you don't get access to the database directly. It has to be through the web server. And this is a way of trying to keep this database safe and secure because this has all the vulnerable data on it. However, SQL injection is a way of getting direct access to this database by exploiting a well-known flaw that's been around for a long time and people are still doing it. So again, the idea here is that the databases on these database servers are created and maintained by what we call a DBMS, a database management system. Database management systems, there are lots of different ones out there, lots of different brand names, but they can all be controlled by something called SQL, Structured Query Language. SQL is kind of like the universal language of databases. Lots of database systems are out there, but they all speak SQL. So if you give it a command in SQL, the database will carry it out. So when a user logs in to a website, the web server sends an SQL query to the database. So I've logged into this website, my username is Mr. Perry, and my password is password123. Very secure. So the web server generates an SQL query to talk to the database. And that would look something like this. Select star from users, where username equals Mr. Perry, and password equals password123. And this will let the database return whether I'm a user of this system or not. Does it have an account that matches these details, yes or no? So if you're a hacker, you want to try and exploit this by using an SQL injection. So SQL can be used to perform most database operations, and this includes operations that are not intended by the database owners. Fake SQL operations can be produced by a technique called SQL injection. This is when the attacker tries to insert extra SQL commands into the input boxes on web pages, hoping the server will carry out these commands and errors. So here's a very simple illustration. Where it says username, I haven't typed in my username. I've typed in an SQL command. I've said select username and password from users. And I'm hoping that when the web server contacts the database server with this SQL command, it's just going to return a list of all the usernames and passwords. And then I can hack the system because I'll know all the information. Now this is a very simple example, and of course in real life it's a little bit more complicated. But you'd be surprised at how many servers are actually vulnerable to this sort of attack. So we've got a bit more information about it here. Again, the idea is very similar. It's just that you're trying to use these text input boxes to slip some SQL to the database server and gain access to the database. There's a lot of very sophisticated ways you can do SQL injections to exploit a range of vulnerabilities. Essentially, this should never happen. There are lots of very good validation techniques that can filter out SQL code from these text input boxes. You should always have some sort of sanitization of the input if you're running a web server to make sure this doesn't happen. But even in this day and age, and this is 2018, I'm still reading about SQL injections. Again, this is because people do not pay enough attention to security. This was a problem 10 years ago, 5 years ago, it's still a problem. People are just not taking the right steps to sanitize their input on their web forms to make sure it can't happen. So just to illustrate this, let's look at another XKCD cartoon. This is 327, and this just illustrates a little bit about how SQL injection problems work, but in a funny way. So we've got a phone call here. Hi, this is your son's school. We're having some computer problem. Oh dear, did he break something? Oh, in a way. Did you really name your son Robert apostrophe close bracket semicolon drop table students semicolon dash dash? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. So good illustration, because the name of her son includes this attempted SQL injection. So when whoever in that school has typed her son's name into their database system, it's run the command drop table students. So that has deleted all the student data. So again, this is the kind of SQL injection that people are trying to do. Either retrieve usernames and passwords or other sensitive information, or damage the underlying database structure. Okay, I'll finish there. Join me in the next lesson when we're going to look at security policies and protections.